Hey guys, so the next skill we're going to develop with these rational expressions is being able to add and subtract them. Okay, so it's basically adding and subtracting fractions gone crazy. So we're going to be finding least common denominators, and with the least common denominators, when we've got rational expressions, there's going to be factoring involved, and then lots of multiplying polynomials. So if you look here at just my quick notes, you might want to jot down. The key is obviously getting the least common denominator, which is the same as least common multiple, just when that least common multiple is dealing with denominators and fractions, and different fractions that you need to add or subtract. Okay, so here are the steps that we're going to do to add and subtract these. All right, we're going to find the least common denominator. We're going to express each term, so that's each little thing that we're going to add or subtract. So we've got number 1 here. We've got 1, 2, 3 terms. All right, express each of those terms as a fraction with that least common denominator. You have to multiply each one by 1 in order to get it that way, and then simplify. Okay, so we're going to begin just very simply with a couple of review exercises on how to add fractions. All right, so this first one, 1/2 plus 1/6 minus 1/3. Our least common denominator is obviously 6, so we're going to multiply this one by 3, this one by 1, this one by 2. Right, 3 over 3, 1 over 1, and 2 over 2 to get 3/6 plus 1/6 minus 2/6. Okay, so we've got 3 plus 1 minus 2 gives us 2/6, and we can reduce that to 1/3. Okay, pretty easy. At the bottom here, our number 2, we got to find our least common denominator. Least common denominator here, you could do this obviously through the ways that we've talked about before. Last chapter, you could do it in your calculator if you know how to do that. All right, you should find that the least common denominator here for number 2 is 70. Okay, so we need to multiply this 2 by 70 over 70. We need to multiply the 3/10 by 7 over 7, and multiply the 5/14 by 5 over 5. So what we're going to get is we're going to have 140. All right, I did this first one actually writing them all out as separate fractions so you can see what we're actually doing. All right, the way I prefer to do it is once you get the least common denominator, you only need to write that denominator one time. Everything else could be written as one joint numerator. Okay, so we got 140 on top minus 21 plus 25 all over 70. Okay, we could do our adding and subtracting. You're going to get 144 over 70, which you can reduce. Okay, easiest way to reduce, I'm doing it right now on my calculator, is just type in 144 divided by 70, then hit math, fraction, enter, and it'll give you the reduced fraction. So you just divide both sides by 2, or top and bottom by 2, and you're going to get 72 over 35. Okay, now that's the easy review stuff. We'll jump into a little bit more difficult things here just with monomials, and then we'll get to polynomials on the backside. So with this one right here, right, what's our common denominator between 6k and 3k? Well, 6k is the common denominator. All you have to do is multiply the second one by 2 over 2. Okay, so that's what I'm going to go ahead and do. All right, this one stays the same. This one will multiply by 2. Okay, so we're going to have 5 minus 8 over 6k. Okay, because you could rewrite this as 8 over 6k, right? If you multiply the top and the bottom by 2. Okay, so we'll have negative 3 over 6k, which can be reduced to negative 1 over 2k. All finished. Now number 4 here. All right, what's our common denominator? Well, we have to have a 2, but we got to have 2a's, so the common denominator is going to be 2a squared. All right, so if the common denominator here is 2a squared, right, that means in order to get this first term to 2a squared, we need to multiply it by 2 over 2. To get the second one equal to 2a squared, we need to multiply it by a over a. Okay, so when we do that, we're going to have 2a minus 2, right, when the 2 is distributed. And the second one is going to be a squared plus a when you distribute the a all over 2a squared, our common denominator. All right, combine everything that we can, and we'll have a squared plus 3a minus 2 all over 2a squared. Now you can't do anything from there because you can't factor that top, so we just leave it like that. It's all finished. Number 5 here. All right, number 5, we're going to find the common denominator first. Common denominator, we know we need a 2 in it. We know we need 3 a's So 2a cubed, and we need 3b's, b cubed. So 2a cubed, b cubed is going to be our common denominator. So with this first term, what do we need to multiply this top and bottom in order to get a 2a cubed, b cubed on the bottom? Well, you just multiply by 2a. We already have 2a's there. We already have 3b's. We don't have to worry about the b's. We just need one more a, and we need the 2. All right, in the second one, we've got the 2, we've got the 3a's. We need 2 more b's, so we're going to multiply by b squared. All right, when we work this out, multiply, we've got 2a on top minus b squared all over 2a cubed, b cubed. That's supposed to be cubed. Sorry. And we can't do any factoring from there. That's as far as we can go, so we're finished. Let's jump to the examples. A couple other monomial ones here, and then we'll get into the polynomial ones at the bottom. Okay, so a little bit more practice here. All right, this first one, we got to find the common denominator. We should see 6 for sure. Okay, we need a squared and b squared. Okay, so what do we multiply that first term by to get 6a squared b squared on the bottom? Just a b squared. The second one, we just need a 2a squared. Okay, the 2 times the 3 is going to get us our 6. We've already got a b squared, we need an a squared. And the last one, we're going to need 6ab. Okay, so when we work that out, our denominator is obviously going to be 6a squared b squared. Alright, but our numerator is going to be a b squared plus 2a squared minus, remember we've got 2, we got minus 2 times all this stuff, so it's going to be minus 12ab. Alright, let's hold it there. So at this point, you always have to make sure that you can't factor the top or the bottom in any way that you're going to be able to simplify or cancel some things out, just like we would have done in the last couple sections, and we can't. So this would be the final answer. B squared plus 2a squared minus 12ab all over 6a squared b squared. Okay, the second one, we're just going to, the only thing that's tricky about this is to rewrite it as 2d over c, right, c to the negative 1. Plus 2c over d, because we've got a d to the negative 1. Okay, so we got to find the common denominator, which is cd. So this first term here, we need to multiply by d. Second term, we need to multiply by c. Okay, in order to get c over c and d over d, obviously. Alright, so our denominator here is going to be cd. The numerator is going to be 2d squared plus 2c squared. Okay, now, once again, you need to check to see if there's any way for you to factor or simplify or anything like that. And you can factor this actually a little bit. You can take out the 2. Right, it doesn't help you a whole lot because you're still left with a sum of 2 squares on the inside, which you can't factor, and you can't cancel out the 2 with the CD, so either one of these would be an acceptable correct answer. Number 3 here. Okay, the last one of this type before we get into the more difficult ones. Alright, we've got to find the common denominator, which is going to be 3xy. So we need to multiply this top one just by 1, so you leave it the way it is. Second one by x, third one by y. Alright, when we do this, we're going to get a 3xy on the bottom. On the top, we're going to have 2 minus x minus y, and you can't do any factoring with that. There's nothing that can be done. Final answer. Alright, number 4. Here's where it gets a little bit tricky. Right, so in order to find our common denominators here, it's a little bit more work to be done. Okay, so you want to factor as far as you can first before you do anything else. Okay, so we got to find what the least common denominator is between these two. Okay, well, since you can't factor the y squared plus 1, it's a sum of 2 squares, and you can't factor the y, you really just need to multiply them together. Okay, so when you multiply them together, our common denominator is going to be y times y squared plus 1. Okay? If you can't do anything else, you know if you just multiply the two together, that it's obviously a multiple of that. Okay, so this first one we need to multiply by y over y. Second one we need to multiply by y squared plus 1 over y squared plus 1. Alright, so what we'll be left with is our y times y squared plus 1 on bottom. And on top, we're going to have 2 times y, which is 2y, plus 5y squared plus 5, because we have to distribute the 5 to the y squared plus 1. Okay? We got to factor if we can. Alright, so we try to see if there's any way to combine this. There's actually no way. If you want to try to work it out, we're going to have a 5y and a y, and 1 times 5. You're never going to get 2 when you add them together, so this is as far as you can go. Alright, number 5 here. We have a over b minus a plus b over a minus b. Now this is one that's a little bit tricky. One thing that you might notice here, of course you could multiply them together. Okay, you could multiply these together, absolutely, and get a bigger factor, but that's not the least common multiple. Okay, the least common multiple you're going to get by just multiplying one of these by -1, because if you notice that this right here, so for example, let's say that a, I'm going to write this as a over negative a minus b. Okay, I'm going to undistribute, I'm going to factor out a negative, and rewrite this problem to look just like this. Now you see that the common denominator here is negative a minus b. So I don't have to do anything with this first problem. I just multiply it by 1 over 1. Second one, you just have to multiply by negative 1 over negative 1. Alright, this becomes a much simpler problem. So what we'll have here is a negative a minus b on bottom, and then a minus b on top. Okay, the way I got a minus b is because 1 times a is a, negative 1 times b is negative b, so that's why I got an a minus b. Now, our a minus b's are both factors here, so you can cancel those two out. You're left with 1 on top, negative 1 on bottom, so your final answer is negative 1. Okay, and the last one here, number 6. Number 6, this is where you want to try to factor these. Factoring the denominators first is probably the best way to get a good common denominator. Okay, so, or the least common denominator. Alright, so I'm going to do this factoring. We've got 5 over, pull out an s, we've got an s minus 1 in there, plus 1 over s plus 1, s minus 1. Okay, the reason I suggest that you do that is because it gets a little bit difficult to figure out what you want to multiply these two by in order to get them to be equal to each other, because you might get tricked into, if you don't try to do the factoring method, you might get tricked into thinking like, oh, we just have to multiply this by s. But the problem is, if you multiply this whole thing by s over s, you're going to get s cubed minus s, which is not the same as this. And if you multiply this by an s, then you're going to get s cubed minus x squared, and they're never going to come out equal. Okay, so if you do it this way, then you know that each of these factors has to appear one time. Okay. So if each of these factors is going to appear one time, then our denominator here, common denominator, is going to be s times s minus 1 times s plus 1. Okay, and that makes it very, very clear for us to see what exactly we need to multiply each of these by. So that means that our first term just needs to be multiplied by an s plus 1, and the second term here just has to be multiplied by an s. Okay, so on the bottom we're going to have s times s plus 1, s minus 1. And on top, we're going to have 5s plus 5. Right, when you distribute that 5, plus s. Okay, so rewrite this as 6s plus 5 over s times s plus 1 times s minus 1. And if we could factor that, we would, to cancel out whatever we could, but unfortunately we can't, so that's the final answer. Okay, I know that's tough. Take some time to go over your notes and be ready for our homework check in class.